Let's analyze another natural hazard that is quite common in the USA and in some other parts of the world, and that is tornadoes. Zoom on your ArcGIS Online map to continental USA. Use Add Layer from Web, an ArcGIS Server web service, and then this string below. As shown here, select Add Layer. After your data adds, show the map legend. Change the base map to topographic. Zoom to the contents of the tornado map data. Your map will look similar to the following. Before you move on, note that you have added a layer that was on a GIS server. This could be very useful for other data in the future that you may wish to find. When you open pre-made maps, it is like having the Lego figure already constructed. But adding data layers is like having access to the individual Lego bricks that you can use to build your own map or figure. Zoom to the USA if you have changed the scale of your map. What is the pattern of tornadoes at this scale in the USA? Turn on the map legend. You can now see that you are only examining Fujita 4 and 5 intensity tornadoes at this scale. You can also see that the dataset goes back to the 1950s. If you want to see the data for each tornado appearing in a pop-up box when you click on them, expand the tornado layers, and for the small, medium, and large scale, use the arrow to the right of each layer and select Enable Pop-up. Again, thinking of this theme of being critical of the data, consider the following. Even though you can zoom into a very large scale for any particular tornado, do you think the spatial accuracy of a tornado recorded during the 1950s and 1960s is the same as that of a tornado recorded during the 2000s? Why or why not? At the USA scale, it does not look like there are any tornadoes, for example, in Colorado. Do you think that if you zoom in, you will see some tornadoes in Colorado? Test your hypothesis by zooming into the state of Colorado. Was your hypothesis correct? Describe the pattern of tornadoes in Colorado and why the pattern looks the way it does. Tornadoes are not devastating because they simply touch down, of course, but because they move across the landscape. Zoom in until you see the tracks of some of the tornadoes. What is the predominant direction that the tornadoes move in eastern Colorado and in most other places in the USA? Why? Again, being critical of the data, you could have a discussion with students here about 1. The fact that the tracks for most tornadoes is not a straight line. Far from it. And 2. The fact that the width of many tornadoes is not a thin line as depicted on the maps, but rather tornadoes can be very wide, such as the Moore, Oklahoma 2013 tornado that was about 1/3 mile wide. Using the measure tool, answer the following. According to this data set, what is the date and intensity of the closest tornado to your school, university, or place of work? How far away was this tornado from where you work? You could, with this same data, assess the vulnerability of certain cities to tornadoes. Examine tornadoes by month of the year, seeing how most January tornadoes are along the Gulf Coast, spreading up to the north by springtime, and then ebbing back to the coast by December. Examine outbreaks of tornadoes on certain days. Look at the time of day that most tornadoes occur, and so much more that we don't have time for in this activity. But I encourage you to come back to this map and data later as you have time.